Welcome to Trig Unit video number 2. In this section, we're going to be talking about inverse trig ratios. And if you look up here at the top left, an inverse trig function is essentially something that solves for the angle. So you put in the sides and it gives you the angle as an answer. In the first video, we talked about how to use the angle as a reference to write a ratio of the sides. Now you're going to input the sides and get an angle answer out. Now before we get too far, one note I want to make at the top of our notes here is to check the calculator mode. And we want that mode to be in degrees. There is something called radians that you will learn about if you take pre-calculus. I'm not jumping into that because you don't need to know it really until you're in pre-calc. So I'm going to practice on this calculator on the right. You're going to hit the mode button, and you'll notice that the third line down it says radian in degree. You want to make sure that yours is probably going to look like this. You want to make sure it says degree, and then hit second quit. So make sure your calculator is in degree mode first, and you're going to want to do that anytime you start to do inverse trig functions, because otherwise you're going to get some pretty weird answers. Now, one of the main things you're going to have to do today is decide which inverse trig ratio to use. So what I want you to do when you're getting ready to start a problem is look at which side you know and which side you want to know. Then, if one of those sides is the hypotenuse, you're either going to use sine or cosine, because tangent is the only function that doesn't use hypotenuse. It's opposite over adjacent. So if you know the opposite and the adjacent, you're going to use tangent. If you use the hypotenuse, you need to decide, is the other side the opposite? If so, that's sine. So, opposite over hypotenuse. If it's adjacent, cosine is adjacent over hypotenuse, then you'll use cosine. And again, that just tracks back to what we had actually talked about in video 1. Sine is opposite, get back to the pen, there we go, opposite over hypotenuse. So you need the opposite and the hypotenuse. Cosine is adjacent over hypotenuse, so you need the adjacent and the hypotenuse. And tangent is opposite over adjacent, so you need everything but the hypotenuse, basically. That's really how you decide. It's not that hard. If you know the trig functions from yesterday's notes, it's the same thing. You just have to decide which one you're going to use based off of the sides that you have and need to know. Now, one other thing I'm going to talk about here in the middle before I start any problems is kind of a refresher. You might not remember this, so I'm going to go over it real quick. All angles in a triangle need to add to 180 degrees. One of those angles is always going to be 90 because trig ratios only work in right triangles. So once you know one angle, subtract it and 90 degrees from 180 to find the third one. And then the other thing we're going to talk about in some of our examples is if you know 2 out of the 3 sides, then you would use Pythagorean theorem to find the third side. That is something we practiced in the first video that we'll do again in this one. But we had not done the 180 degree rule for triangles yet, so that was new. Now I'm going to zoom in on this first example and just kind of jump right in. So currently I know 6 and 8. Now in order to decide if that's opposite, adjacent, or hypotenuse, I need to pick an angle first. So I'm just going to pick angle A. Okay, so I'm going to go ahead and write my A. And then the trig ratio I'm going to look for, this would be the adjacent. This would be the hypotenuse. This would be the opposite. So I don't really care about the opposite right now, because I need to know angle A, and I'm using the 2 sides that I already know. I don't know the opposite. I could use angle A to find the opposite once I know it, but I can't find the opposite if I don't know angle A because that's 2 unknowns. So I'm looking at the adjacent and the hypotenuse. Adjacent and hypotenuse is cosine. So basically the cosine of A should be 6 over 8. because remember cosine's adjacent over hypotenuse. The inverse trig function is how you get a by itself. So if I want to get rid of that cosine, I can't just divide by cosine. I'm going to do the inverse cosine of 6/8. And in my calculator, the cosine button is right here. What we want to do is hit second and then cosine, and then 6/8. And we're going to round to the nearest tenths place, because that's what it says right here. So angle A would be 41.4. And I'm going to go ahead and write that right here. And I'm going to go ahead and label it right here. Now, before I move on, I should write a degree symbol so that I know that that's not a side length, it's an angle measure. And then, now that I know one of my angles, to find angle B, I would take 180 minus 90 minus 41.4. 180 minus 90 minus 41.4. That's 48.6. Now I have one thing left to find, and that is side length CB. So if I do want to know that opposite side, the one I was talking about over here, and to make things easy, I'm just going to call it X for right now. I can use either angle A or B, but since I've already marked angle A, I'm going to use that one. Now, as I kind of just erased, that would be the opposite. So in order to find that side length, I would need to do the sine of angle A, and it would be X/8. Now, to get X by itself, how do I undo division? I multiply. And then I would just take my calculator and do 8 times the sine of 41.4. That's 5.29. And that side length is BC because X is between B and C. Oh, sorry, I should have called that 5.3 because we're rounding to the nearest tenth on this one. Now we're going to practice this 3 more times. Each problem is a little different because you're going to know different information. But one of the main differences between this problem and the next one is on this one I knew 2 side lengths, and if I look ahead to the next one, I only know one side, but I also know an angle. So if you already know an angle, my suggestion would be take the easy route first and go ahead and say that angle B is going to be 180 minus 90 minus 65. That's 25. Now technically that's an angle measure, so we want to go ahead and write the degrees on it. So if you know one of the angles, you don't have to use trig to find the other one, you just subtract from 180. Now I need to find the other side lengths. Doesn't matter which one you find first. I'm going to go ahead and find this one first. If I want to find that one, and I'm going to use angle C, which is 65, this would be my opposite, this would be my hypotenuse. Which trig function uses opposite and hypotenuse? Sine. So sine of 65 equals opposite 16 over hypotenuse x. Now this one's a little different because I need to try and get x by itself, but to get rid of that fraction I have to multiply by the thing on the bottom, which happens to be x. Now that's going to cross this out right here, and this is the part where it gets a little weird, so I'm going to go ahead and rewrite x sine 65 equals 16. You don't have to do that step, you could use what you already had. But now, to get rid of the sine 65, I can divide by sine 65 to the other side. Here's why. This is multiplication, right? The opposite of multiplication is division. Sine of 65 is just a number. So you can divide that number to the other side. What you can't do is divide by sine, because it's a function, so you can't divide by it without the 65. That's why we have to use inverse trig if we need to get rid of sine. But there's a number there, so we don't need to just get rid of the sine, we can get rid of the whole thing. And then I would just do 16 divided by sine 65. And that's about 17.7. That 6 has a 5 after it, so that would round up. Now I have to go check because I have two side lengths left. X is between B and C, so this would be side BC. Now you can use trig to find the last side if you want to. Personally, I don't love that idea because it's a little bit more complicated. So instead, I'm going to use Pythagorean theorem. I'll go ahead and call this y. Now I already know the hypotenuse, so instead of adding my two squares, I'm going to subtract them. We had talked in our first lesson about how if you want to find a leg, you take the square root of the hypotenuse squared minus the other leg squared. That's where that's coming from. Some of you might remember that well. Some of you might be like, oh, I totally forgot about that. If so, you might need to go back and watch that video. So I'm going to type in my square root, 17.7 squared minus 16 squared. The reason I would do this all in one step is because 17.7 squared is obviously going to be a decimal. I don't want to have to remember that decimal and get it typed in correctly, so I'm just typing it all in like that. That's 7.56, so I would just call that 7.6. Now if I look at y, it is between, let me make this a little smaller, A and C, so that's AC, which is good, because that's the only length I haven't put in there yet. Okay, I'm going to kind of zoom out and let you guys write that down. Make sure you get caught up if you need to before I do the last two. Okay, on the last two, there shouldn't be anything brand new. This is just more practice or another example. I know my angle A is 42 on this one, so I'm going to say that angle C is 180 minus 90 minus 42. Again, that 90 is because B is 90 since it has the right angle. So 180 minus 90 minus 42. That's 48. So angle C is 48 degrees. Now I can go find BC if I want to. BC is my next one on my list, so I'm going to go ahead and put an X between B and C. If I want to find that angle from the 42 that I already know, this would be the, if I want to find that side from the angle I already know, that would be my opposite, this would be my adjacent, this would be my hypotenuse. Now I don't really care about that hypotenuse yet because it's not what I'm looking for and it's not what I know. So I'm using opposite and adjacent, which has to be tangent because it's the only one that doesn't use the hypotenuse. Opposite over adjacent would be x over 50. And to get rid of that 50, since it is in the denominator, you would multiply it to the other side. So x is going to be 50 tan 42. Which is 45.02. But that 0.0 would just stay there because the 2 isn't big enough to round up. So BC is 45. Now, kind of like I said before, I'm not a super huge fan of using trig if I don't have to, like sine, cosine, tangent. So instead, since I know that this is now 45, I'm looking for the hypotenuse, and the hypotenuse is always the square root of each leg squared and added together. So this hypotenuse, AC, would be 50 squared plus 48 squared inside of the square root. So in my calculator, I'm going to type square root 50 squared plus 48 squared, 69.3. Moving on to our last example, I'm back to knowing 2 out of the 3 sides. I don't know any angles yet. When you don't know any angles yet, pick one to start with. I'm going to pick B, for example, and I will fix this on the notes. But what side do I already know that AC is 5, so we're going to change this one to the measure of angle B. If I want to find the measure of angle B, I know the 5 is on the opposite and the 7 is adjacent, because this side over here that I don't know is the hypotenuse. And since I don't know it, I can't use it yet because I'm already looking for B. I don't need another unknown. So since I have opposite and adjacent, that's going to be tangent of angle B equals 5 over 7. Then to get rid of that 7, or sorry, not to get rid of the 7, I don't need to because I'm not looking for B over there, I need to take the tangent inverse to sort of undo that tangent so that I know what angle B is. Anytime you're looking for the angle, you're going to have to use an inverse function. Now, second tangent, try it again, second tangent of 5 over 7. It's about 35.5 degrees. And now that I know that that angle is about 35.5, angle C is 180 minus 90 minus 35.5. Now, one trick of the trade, 180 minus 90 is 90, guys, every time, because 90 times 2 is 180. So instead of entering all 3 of those, you could just do 90 minus 35.5. You don't have to do the 180 minus 90 because you know that's going to be 90 every time. Just a little bit of a shortcut there. So that's 54.5. And then I need to find angle B, or side length BC. That's my hypotenuse. So just like I talked about on the last one, that side length is going to be the square root of the other 2 sides squared and added together. That will be a minus if you have the hypotenuse. But we do not have the hypotenuse, so it is plus. Square root, 7 squared plus 5 squared, 8.6.